Inverse variation is what we're talking about today. And so in 8th grade and 7th grade, y'all talked about direct variation, and you may have touched on it a little bit more in Algebra 1. And that's when something can be multiplied times a constant. So you'd have something like y equals kx. And you're just having a number multiplied here. That was direct variation. We're going to be looking at inverse variation. Inverse variation is when you have a number divided by x, and that number is a constant variation. That number is going to be a single number. So like maybe 5 or 6. And so that's one of the first steps on finding these. If you're having to come up with the equations, you need to find your k first, and then you can write your new equation. So let's look at examples of tables that have both direct, inverse, or neither variation. And how you can tell if it's a direct variation. Direct variation, you should be able to divide and it be a constant number. And you always divide y divided by x. Inverse variation, you should be able to multiply and come up with a constant number. So x times y should all equal the same number. Now, when you're modeling and it's real life data, you're trying to find the one that's the closest, and you can find it with multiple ways. And so we're not going to use a computer to help us find it, but on all the examples I'm giving you in these, you should be able to find what the majority of them are multiplying to, and that's what you'll be using. So let's look at this first chart. So first off, let's check our numbers. And I always start by testing for direct first. And I take a couple of them, ones that are easiest for me to multiply. So 2 times 15 is 30. 10 times 3 is 30. 15 times 2 is 30. And 4 times 7.5, if you actually go in there and do the math for that, that's actually going to equal 30 as well. So that means if they're all multiplying to equal that same number, that this is a inverse variation, because that's a constant setup there. And I'm going to go ahead and copy this so we have it for the next page. But we now need to come up with the function model. And so the function model is going to be y equals whatever this number is, so 30 divided by x, because this number is your k. So let's go ahead and, so this is a inverse, and that's the function. So let's look at this next page. And so again, when it's direct, we divide, and it comes up with a constant number. When it's inverse, we multiply, and it constant comes up with a number. So let's look at this set. And I'm going to first test out inverse. So we multiply by 2 times 10 is 20. 4 times 8 is 32. So that did not work. So the next thing we need to do, so we know it's not inverse. Now let's test and see if it's direct variation. And so y 10 divided by 2 gives me 5. 8 divided by 4 gives me 2. So that doesn't work. So that means this one is a neither, and you don't have to actually find the equation in this case. Let's do one more. And so we're again going to start off by looking for, is it direct or inverse? And inverse again is the easiest one to test, and so let's take them and multiply. And so 0.2 times 8 gives me 1.6. 5/10 times 20 gives me 10. So it is not an inverse. Now let's check out direct. So I take my y, 8 divided by 2/10 gives me 8 divided by 2 is 4, and move the decimal place. 20 divided by 5/10, and that is 40. 40 divided by 1 and 0.0 is 40, excuse me. And 1.5 divided by 6, excuse me, I went backwards on that one. 60 divided by 1.5 gives me 40. So my K again is 40, but this time I need to use my direct variation formula, which is y equals kx. So y is equal to 40x. And this is a direct variation. So let's look at, we're going to go into the inverse and the joint and ones that vary jointly, a little bit more detail. So suppose x and y vary inversely. That means I'm in this formula of y equals k over x when x is 4 and y is 12. And so we first need, step 1 is going to be to find that k. So y was 12, x was 4, and our k is in our numerator. What would I need to do to solve for k? Well, multiply both sides by my LCM, which is 4 over 1. And so I'm multiplying both sides by 4. On this side, the 4's cancel out. And 4 times 12 is 48. And that is my k. So the next step asks me for what the graph looks like. And the graph, you can use your graphing calculator to help you find it, but you just do a table, x, y, and we're only worried about the positive values. And so when x is 1, we first need to find the equation before we can actually plug it in there. Sorry, I didn't realize I forgot to stop it. I stopped before I got the equation. So y equals our k, 48, divided by x. This is our function model. This is the answer for A. So if x is 1, 48 divided by 1, y would be 48. At 2, 48 divided by 2 is 24. 3, 48 divided by 3 is 16. 4, 48 divided by 4 is 12. And we keep going. And you'll see that you have a chart, and this kind of shows you some more further on in this chart, and then you can plot it on a graph. So the last step, on step C, it asks us for what is y when x is 10. So you're going to take that 48, and you're going to replace the x with 10. And so y is 4.8 if it wants it as a decimal, and it would be 24/5 if it wants it as a fraction. So just watch the blue whenever you're doing this lesson on MathXL, because it will tell you what format it wants the answer in, if it wants it in decimal or fraction. I want you to find out what is the function model when x varies inversely with y, when x is 8 and y is -7. So you should have come up with y is equal to -56 over x. And so now we are going to be working on doing a model of real life situation. And so like I said, on these, it may not fit perfectly for each one, but we're going to look at the number that's closest to. And so we're going to first try to find K. And if you're ever given a chart, remember that multiplying these numbers will give you K. And so we need to multiply all of them through. So 3 times 85. And that gives you 255. 3 times 51. Or excuse me, 5 times 51 gives you 255 as well. So it looks like 255 might be our number. And 12 times 21 is 252. 17 times 15 is 255. So as you see, a consensus number, for the most part, we're having 255 as your K. So the model that would represent this and is that 255 for your K. So 255 over X. And so if we wanted to put it in the terms of this, they didn't use X and Y. They use T and N. So you could be writing it like this, or you could have had it as N is equal to 255 over T. So what could ask how many students would it need to take if they weren't able to get it all completed in 30 minutes? Then you would take the 255, you need this model because you would want to find the number of students. So you take 255 divided by 30, and you'd find that N was 8.5. We can't have a partial student, so it'd be 9 students. Oops. I want you to try to find this next one. So on this one, we found out that K was going to be 255. And then when we start trying to figure out what your N is, what your formula is, you came up with N is equal to 255 divided by T, or T is equal to 255 divided by N, but neither one of those are the options. Another way of writing these when they're inverse variation is you can actually multiply your X times Y is equal to your constant. 225, excuse me, not 255. And so that would be your direct variation. So besides for the direct variation where you may have just one, or inverse where you just have it divided by, you can also have varies jointly. And that means there may be more than one thing. And so if it, or combination of variations. So if it says varies jointly, that's the direct variation where you're multiplying it times your K. And so, okay, remember that K is a number. Oh gosh, that was awful. There we go. And all the others are going to be numbers or variables inside the problem. And so anytime it varies jointly with it, that's going to be in the numerator. Inversely, it's going to be in the denominator. And sometimes it'll say it varies directly with x squared. And so then you'd come over here and you'd have an x squared. So it doesn't always have to just even be that variable. It may be that variable squared or cubed or something else done with it. So let's go ahead and look at a couple of examples of this. So if we want to look for the number of bags of seed needed to reseed a yard, it varies directly with the area, as that means it's up here in the numerator, and inversely with the weight, and then we're going to have our K, because it's a variation. So we first need to find out what is your K. And so plug in the information we have. If it takes 2 3-pound bags of seed for an area of 3,000 square feet, 3,600 square feet, how many 3-pound bags of seed will seed a 9,000 square feet? And so let's find out our bags of seed. And that first one, it takes, so N is the number of bags of seed we had. And so we had 2. And so 2 is equal to the area, which was 3,600, times our K divided by the weight. And each bag's weight, because it's a bag of seed, which is 300. Or which is 3 pounds. And so I need to take and divide 3,600 by 3, and I get 1,200. K is equal to 2. Divide both sides by 1,200. And we have K is equal to 1 over 600 when we reduce that. So we're now going to find out how many bags of seed will we need, how many 3 pounds bag of seed we'll need for 900 square feet. And so N is our number of bags, is equal to area times 1 over 600 divided by our weight. And so in this case, that means N is equal to 9,000 times 1 over 600 divided by our weight. And so, assuming our weight, which is 3. And so we're going to go ahead and rewrite this. That's 9,000 over 600 times 1 over 3. Or if you want, let me take that back a step. Where that came from is this was divided by 3, which when we divide, that means we keep, change, and do the reciprocal of the other. And so reduce what can reduce. 9,003 gives you a 1 and a 3,000. Oops, about 30,000. And then reduce again, 3,600. And that will go into there 5 times. And the 1's here. So that leaves us with N is equal to 5. And so what 5 was is 5 bags of seed. And so how many bags, if you vary jointly with, you're planting, excuse me, let me start that over. How many bags of mulch will you need to cover a planting area that varies jointly with the area of the mulch in square feet and the depth of the mulch in feet? If you need 10 bags to do 120 square feet at a depth of 3 inches. Be careful. You need to first convert those inches into feet. And then you can solve this. So take some time and solve this on your own and choose the right answer. So we found out in that first one that on our sample one is 1/4 of a foot, and so K ended up being 1/3. And then when we plugged it back in, we used that 1/3 for our K, but we found that the depth this time was 1/3 of a foot. And you came up with 22 2/9 of a bag, which means we'll have to round up and get 23 bags or we won't have enough. The gravitational potential energy is a measure of energy. PE varies directly with the object's mass and its height in meters above the ground. Physicists use G to represent the constant variation, which is gravity. Gravity is 9.8. The skateboard in the photo has a mass of 58 kilograms and a potential energy of 2273.6 joules. What is a gravitational potential energy of a skateboarder with 65 kilograms of a skateboard on a half pipe shown?